This is how I'd use the simulation in front of a class to visualise the meaning of potential difference and how it can be measured using a voltmeter. I'll probably introduce it by saying something like, we've seen that the red stuff represents energy and that voltage or potential is shown as the amount of red stuff each charge has. The amount of energy per charge is the same everywhere on the left-hand side of the circuit. 6 volts, 6 volts, 6 volts, 6 volts, 6 volts, 6 volts, 6 volts. And the charges on the right-hand side don't have any energy at all. So everywhere on the right-hand side is at the same potential of 0 volts, 0 volts, 0 volts, 0 volts, 0 volts, 0 volts. We've also seen that the amount of energy per charge decreases as the charges move through the bulb filament. So the potential decreases through the bulb filament. 6 volts, 5 volts, 4 volts, 3 volts, 2 volts, 1 volt, and then 0 volts, 0 volts, 0 volts again. We can't measure potential directly. We can only measure the difference in potential between 2 points. That's the meaning of potential difference. And it's potential difference that voltmeters measure. A voltmeter has 2 leads. You connect each lead to a different point in the circuit. And the voltmeter tells you the potential difference between those 2 points. So if I connect one lead to the 6 volt side of the battery and the other lead to the 0 volt side of the battery, then the potential difference is 6 volts minus 0 volts, which is 6 volts. What do you think the potential difference across the bulb would be? It would be 6 volts. And what would the potential difference be between any point on the left-hand side and any point on the right-hand side? It would always be 6 volts. That's why the potential difference across the battery is always the same as the potential difference across the bulb. Current is all about flow, which is why we talk about the current through something. But potential difference is just about comparing 2 values, normally either side of a component, which is why we talk about the potential difference across something, like a battery or a bulb. What would happen to the reading on the voltmeter as I change the battery voltage? Well, it would change too. What would be the potential difference between 2 points on the left-hand side of the circuit? It would be 6 volts minus 6 volts, which is 0 volts. Everywhere on the left-hand side of the circuit is at the same potential. So the difference between 2 points is always 0. Most circuits at school are built using plastic insulated leads with a plug at each end, which means you can only measure the PD between points where you can actually connect the voltmeter. It's worthwhile making a circuit out of thick, bare copper wires if you can, to show that the potential is there everywhere in the circuit, not just where it's easy to connect a voltmeter. In our simulation, we can also measure the potential difference between 2 points that would be impossible in a real circuit. For example, when one of the points is in the middle of the bulb filament. The middle of the bulb should be at a potential of 3 volts. What do you think the potential difference would be between this point on the 6 volt side and the middle of the bulb? It would be 6 volts minus 3 volts, which is 3 volts. What about the potential difference between the middle of the bulb and this point on the 0 volt side? It would be 3 volts minus 0 volts, which is 3 volts again. What about the potential difference between this point, which is at about 4 volts, and this point, which is at about 2 volts? Well, it should be 4 volts minus 2 volts, which is 2 volts. It's always worth emphasising how batteries behave when you change the circuit. What would happen to the reading on the voltmeter if I changed the resistance of the bulb? It wouldn't change, because batteries are constant voltage providers. If you change the resistance, it's the current that changes, which you can tell from the speed of the charges. But the pattern of the potentials around the circuit stays the same. So why is there a potential difference across the bulb? Why do the charges have more energy on one side of the bulb than on the other? It's because in the bulb, energy is being shifted from one store to another. In the bulb, the chemical store of the battery is shifted to the thermal store of the surroundings. Whenever a component shifts energy from one store to another, there's a potential difference across that component.